Hey guys, Adam with FANUC here. Today I want to show you guys some slightly more advanced programming techniques, something that utilizes this section called machines. Very useful for making simulated conveyors, index tables, elevators, lifts, all kinds of fun motion outside of just what the robot is doing. This will be a tad more advanced and fast-paced. So if you haven't, please go watch my RoboGuide tutorial to get caught up to this point, or also reach out to your local FANUC office and take some RoboGuide training, handling tool training, things like that, because this video is just going to focus on what we call machines for ancillary motion. So we'll get started, and away we go. I've got a nice R2000 here. I just slapped on a vacuum gripper. Doesn't much matter. Next, we need a part. Go to my CAD library. Bring this over. You guys know I love to move cars around, because why not? Coupe, that's a good name for it. Let's see here. Let me see if I can define a custom color. One thing I noticed earlier is the visibility. I've turned off my visibility in the past. Sorry about that, guys. Visible. Habit that I get in is I keep this rack invisible. You might know that too. Here's my green car. I need to make it much smaller. It's going to be a toy car. It's an RC car because I want it to be an RC car. There we go. Nice green RC car. Let's get rid of that rack again. All right. Next, how is the robot going to carry the car? Open up my tool, look at my parts, apply it, edit. And when I pick it up to carry it, I want to carry it something like this. Go ahead and get that aligned. Perfect. And it needs to vacuum onto the roof of the model RC car. Right? Perfect. Let's all kumbaya agree on that. Apply. Next, simulation, that's fine. We don't care about that. Okay, we need to bring a machine into this party. So typically, and what you've seen in my previous tutorials is I go into a fixture and I add fixtures into the system, and then you pick and place parts from your fixtures. Same idea, but now with machines. So I'm going to right click, add a machine. And I'm going to just pick one from the FANUC CAD library. You can bring in your own machines. You can draw your own, import it from all things. I'm just going to use what's already made available to me because it's easy. Now, when we say machines, you can literally have machines, CNC machines, robo-drill machines, things like that. But that's really not what I mean. Perhaps what we call it is a little misleading, because a quote-unquote, air quotes, machine is anything that moves. So for me, I'm actually going to use a fixture as my machine because that's what I want. In fact, I just want it to be a dumb little everyday rolling conveyor. All right, so this conveyor is going to be a machine, but really it's just what it is. So let's go ahead and let's get it positioned. Let's bring this guy down to earth. Somewhere around there looks pretty good. I'm going to top view and get her a little lined up so it actually presents parts to the robot in a nice fashion. No science here, guys, just making it pretty. Something like that, right? Why not? So now I have a conveyor, but you'll see in the properties dialog box, it's a machine. In fact, let's name it the in-feed conveyor. Okay, apply. So here it is. Now, the only thing that really sets this apart from fixtures is that it is prepped and ready to do motion. Now let me show you how to do motion. After you've installed your machine, the next thing, right click, add a link. A machine link is going to be the part that moves, all right? And so as the hierarchy is being built, the machine is the thing that doesn't move, right? The conveyor is going to sit still, and then the link is what's going to ride along on the conveyor. So I need a link. Again, I can do whatever I want, but I'm going to just grab a FANUC pre-built thing because it's super easy. And I want to have a pallet. All right, I want my little car to arrive on a little wooden pallet because I think that's funny, and no other reason other than this is going to be whimsically cute and funny. So here we go. I'm starting to build this together. You see that my property dialog box now has a link. We can more appropriately name it as the pallet. And look at my hierarchy here, right? I've got the in-feed conveyor, and then the link that will be moving is the pallet. So now we got to do some work with that. First here is on the general tab is the axis origin. This is where the part is going to start its motion. Now, if I move this up, look what RoboGuide threw in here. They threw in a little servo. This is pretty just representative. It doesn't actually mean there's a servo. So we did not actually add a 7th axis servo here as per what I just clicked. This is just representative to show what direction, X, Y, or Z, this part is going to move. And in a minute, we'll say, is it going to move linear or is it going to move rotating? So if we want to do a dial table. And then we can also say, do I want to move along the X, Y, or Z? And it shows me that. I can also have some fun with this. I'm going to tilt this thing. I'm going to point my Z axis toward the robot. There's a lot of ways to skin this cat, guys, but I'm showing you it this way. And I'm going to just kind of halfway hide this motor back here, almost like it's bolted to the back of my conveyor. No one will ever really care, but now I have this axis origin with a Z axis, just because this says Z, pointing toward my robot at the origin here. That's going to be important in a minute. See when I click apply? When I click apply, it now wants to move my link in that Z axis. I could have left my motor hanging up vertically in space and said X axis, but I'd rather have it be this way and then go to my link CAD tab. So now we got to talk about the link CAD. The link CAD is this palette, all right? It is what are we looking at? So I'm going to click on this guy, and the first thing I want to do is get this thing sorted out a little bit. I want it to rest on the conveyor. It's also far, far too large. Let's go half scale in X, Y, and Z to make it more RC car size. So now we got a little palette. Go ahead and get it somewhere around here. There we go. This is basically for viewing purposes. This is all aesthetics. This is just to look good. In fact, I probably could have mentioned earlier that if you are wanting to do conveyor tracking or have multiple boxes show up for palletizing, you should be using the FANUC IR Pick Pro version. It's a subset of RoboGuide because Pick Pro will send parts down a conveyor. Or you could use Pallet Pro and you can do palletizing. Machines here are just to look pretty. That's why this link CAD, I just want it to look good. Now, in a minute, I'm going to put a car on the pallet so that the car rides on the pallet down to the robot to be picked. What if I wanted the car to just ride on the conveyor without a pallet? Boom, invisible. So no matter what you do with a machine, you do have to add the link and it doesn't have to be a pallet. Your link could be a whatever. It could be a box. It could be anything. Just make it invisible. So now what would happen is the car would roll along the conveyors, and to the viewer, it just looks like the car's on the conveyors. But to you, the programmer, you'll know that the car is riding on an invisible thing. For me, I'm going to keep it visible just because it's easier to show and understand. And again, I think tiny pallets and tiny cars are fun. So there's that. Let's go ahead and get into the parts. I want to put my coupe, apply, onto this pallet. So let me edit my part offset. Car is currently inverted, so let's go ahead and fix that. And let's rotate it. Things are looking good. Let's set it on the pallet. Beautiful. Getting everything nice and square and straight. Let me hit apply. So now I have a nice little machine with a nice little pallet link with a nice little car riding on the link. I now have all the ingredients I need to start setting this thing up for motion. So to get into motion, we have our pallet link properties box open. I'm going to go, first I do want to do my simulation tab that just says I am going to pick up a car from this pallet, but I'm not going to place a car on the pallet. That's just good practice to know what the robot's going to do. But right here's the motion tab. Now by default, RoboGuide wants you to control things with servos. That's what we do, servo company, right? So in the real world, you might have your R2000 with a 7th axis, right? J1 through J6 are here. You could have a 7th axis, and you could program this thing if you had a chain conveyor or something like that. And the robot could actually control the ancillary motion of this system. But for this I don't want it to be that fancy. To set all that up requires work, and it requires math and stuff that I don't want to do right now. I just want it to look cute. In fact, maybe somebody just kicked this pallet and it rolled to the robot, right? So we're going to do it a lot simpler. Where it says servo motor controlled, I'm going to change it to device IO controlled. Now look what it does to my dialog box. It says, do you want your axis to be rotary or linear? Well, for this guy, I want it to be linear. Click. And then I can look at speed or time. I'm going to do speed. I'm going to say this thing is going to come toward the robot at 1 meter a second in the forward direction, positive, and in the negative direction, sure, another meter per second. Okay, apply. How am I going to run this thing? Well, I am going to have the robot controller use digital output 1, and when digital output 1 is off, I want the pallet to be at 0, the origin. Then, when the robot digital output 1 turns on, let's send it 3 meters ahead. Apply. Look what it's starting to do. It's starting to piece this together. If I pull up my teach pendant and go to my I/O screen, digital I/O, digital output 1, watch what happens when I turn this on. Boop. The whole pallet, the link, moved forward exactly 3 meters. There's 0, there's 3 meters. 0, 3 meters, 0. So I'm looking at this, I also see that I'm not quite to the end. Easy peasy. Let's just dial that in. Let's go a little farther, 3,200, right? Apply. There we go. So now when this guy turns on and off, off, on, off, on. So look how simple this is. I now have a robot that just by turning I/O on and off, I'm able to move this part along a conveyor. This outputs section, this is where the conveyor can signal to the robot and say, yes, I'm there, I have arrived. So you can say things like robot digital input number 1 will turn on when the pallet reaches 3,200. That way, in your program, the robot can say, turn on and start moving, and then it can wait until DI turns on, and we know we're there. So before I go too hog wild banana sandwich on this thing, let's just test this, okay? Let's go select, create, let's make a little test program. Edit. I would like to take a digital output, number 1, turn it on, and then I'll just say, let's wait 4 seconds. Then after 4 seconds, turn it back off and wait another 4 seconds. There's my code. Turn it on, wait, turn it off, wait. And let's see how this thing runs. This is a good way to test our machine. Turn it on, pallet comes to the robot, turn it off, pallet goes away from the robot. So now I have simple basic motion that works. In fact, we could also here do a wait for DI. Let's test that, make sure that's working. Let's wait for DI1 to come on. Make sure that works. Run forward. Part got there, came back. Look at that. So this is showing how easy it is to get this part to move all along this conveyor. Let's go ahead and we're going to do this basically again, and I'm going to show you on a rotary side, and then we'll go ahead and stitch it all together, right? We'll have some fun here. So let me minimize that. Let's make another machine. I'm going to make a real crude something. Let's take a, how about we start with just a table. Let's do an index table. We'll start with a fixture. How about this guy? Sure. So this will be my stationary bit. So this guy will just park here, bring him down to earth. Look at that. Okay. That's good. I'll call this a dial table base. All right. And then the dial table needs a link. For the link, let's make a cylinder. Let's go into our link CAD first to make sure that we have this right. Now this time, look, I'm going to keep the Z-axis facing vertical on this one because I'm about to make it be a rotary axis about the Z. It's asking me to align the origin along the Z. So I'm going to keep that one vertical. I'm not going to lay it down. My link CAD, I want it to be gray, and I want it to be a lot thinner, and I want it to sit. How do I want it to sit? How about like this? Give it a little larger diameter here. Look at that. We're building a dial table. I'm going to change the color so we can see it a little bit better. All right, I have a nice blue dial table. Next, I need to put my parts on there. So I need a coupe. There it is. Let's go ahead and get this thing seated onto my dial table properly. A little something like that. Perfect. Looking good. Apply. It will not be visible at runtime. Don't need that because I'll be putting it there. As far as my simulation is concerned, I will not be picking from the dial table, but I will be placing to the dial table. Wonderful. And let's go back to our motion. device I/O controlled. Now this one I'm going to leave it as a rotary instead of a linear. And degrees per second, I don't even know. Let's just do, we'll go quickly, 45 degrees per second. It will also be controlled by robot number 1, but it will be controlled, let's use DO number 2, since DO number 1 is being used for the conveyor. And here we go, DO number 2. So in this case, because we're talking about degrees, in the off position, I'll have it be at 0, and in the on position, I'll have it be at 90 degrees. We'll have this thing do a quarter turn. Apply. So let's go ahead and test our outfeed dial table just to make sure that that works. Let's be good programmers also, and let's name these. DO1 should be conveyor, and DO2 should be dial table. Be good programmers. All right, let's see what happens. On, off, on, off. Perfect. So now I can actually rotate this table using my I/O. If we want, we can do a little test. The only thing is, if we're going to test it, we got to go back to our parts and let it be visible at runtime just for the test. So select test DO2. We'll do a little wait. Let's wait, let's see, 30 degrees, 4 seconds, why not? And then back off. Here we go. Let's see if our dial table works. Rotate the car forward. Rotate the car backwards. Super. So now we have a nice working in feed and a nice working out feed. Let's go ahead and piece this all together into something fun, right? Like let's make a little simulation out of this. So here's what we're going to do. New program. Create. Fun. Edit. I like to throw a bunch of lines of code in there so I can jump around easier. Let's start out with the best 4 lines of code that anyone can ever write, which is your user frame. I'm doing everything in world. My user tool. I got tool 1 is my vacuum. Let's make sure payload is declared, which I did before y'all started watching this video. And lastly, let's do a speed, miscellaneous, override speed. Let's just start at something mediocre. Okay. We also need to teach some positions, don't we? Let's go to my PRs. We're going to need a home. We're going to need a pick. We're going to need a place. And I'm going to want a Z offset so when I pick up the car, I can move up. Let's just call it 150. So my Z offset will be nothing, nothing, 150Z, nothing, nothing, nothing. Home position, that sure looks like a wonderful home to me for today. Home. So now we just need to teach the pick and the place. Well, let's look at the place first. If I open up the dialog box for the coupe, I can tell the robot, I gotta fix this too. I can tell the robot move to. So there's our place position. That's easy. Shift, record. But for the pick, I gotta get this link over here to a reachable position first in order for me to teach that. So let's go to my I/O, turn that on. So now the part is actually reachable. Click here, move to, there it is. And also notice that the car is facing forward here and backward here. So the robot should intelligently move those around for me. Data, pick, shift, record. All right, I have a home, I have a pick, I have a place, I have an offset, I have a bunch of I/O, I have so much fun ingredients. Let's turn this into a program. I'm going to start by doing a joint move just to get to my home position. Let's say PR1 home. By the way, I need to send him back. So we'll start off at home. And the first thing we need to do is have the pallet come to us. All right. So digital output 1 is going to turn on. And then we will patiently wait until the part says that it arrives as we programmed. And then we got to go get it. Let's say linear to PR2, which is the pick. Let's go quickly with a CNT 25. And I want my offset, which I think was PR4. Yes, it was. So this will put me 150 millimeters above the pick position. Copy, select copy, and let's go paste. Paste. Don't need a choice there. We'll let that be a fine. So we're above it, we're down to it, and we're above it. While we're here in the middle, we'll have to do our pick logic, which we'll do in just a moment. So there's that. So after we pick it, now we got to go place it. So edit, copy, select these lines of code, come down here, paste logic. Muy bien. Place, place, place. And then when all the work is done, the robot needs to go home. We'll do a linear command to go home. Linear choice PR1 quickly to go home. And I can clean up the rest of this. Don't need any more spare lines of code. Super! That looks like a program. Let me do a split screen so y'all can see what I just built. It'll show it a little better. Best 4 lines of code. Start at home. Start the conveyor. Wait till it gets there. Pick up the part. We still have to add our simulation here, but pick up the part. Place the part. We got to do our simulation there. And then after we place it, we're going to go home. But you know what else we should probably do? Let's insert a couple lines of code and we'll spin the conveyor. DO2 is going to go on. That way the conveyor goes, and just at the end here, I'll just make sure it has enough time to get done. All right, that is a good looking simulation program. We need to set our pick and place logic. Y'all might remember how to do this. Add a simulation. I'll call it pickup. And I want to pick up the coop from the in-feed conveyor pallet using my gripper. And the other program I need is a drop. And I will want to drop my coop from the tooling onto the dial table base link 1. Hook those into our program down here. So right here, I'm going to say call pickup. And down here, I'm going to say call drop. We get to test this now, guys. Here we go. Get this on the screen, something like that, so we can see what's going on. There, that's a better view. Right there, right there. All right. And let's see how we did. Robot's at home. Pallet arrives. Robot gets the car, spins it around, places on the table, sends the table around. That, my friends, is how you use your machines. One thing I'll note to you is now here at the end of this program, you'll see that both of my DOs are on. If you want to rerun the program, you'll have to turn those back off to reset your parts, or you can always do that programmatically, either at the beginning or the end of your program. Just have DO 1 and 2 turn off. But yeah, that looks pretty fun and fancy to me. Part comes in, robot goes and gets it, places it, onward she goes. All right, guys, that is the quick and easy and fun way of using machines to generate motion in a basic handling pro sim. Keep in mind, if you were going to do this high speed or repeated, you would use the IR Pick Pro or the Palette Pro. But for things like this, where you just need to, use it as a test, a sales tool or a reach tool, cycle study tool, things like that, this is highly, highly effective and honestly pretty easy to work with. So if you have any questions, feel free to put them in the comments below or reach your local FANUC office. And as always, have fun coding.